Hello again, everyone. It is time for math lesson number 3. So you just tried these questions. Let's talk about how I would do them in the non-traditional math class kind of way. In other words, we're looking for tips and tricks to get through these questions to find a correct answer faster than if we were to work them out the old-fashioned traditional way. So questions 1 and 2 are referring to this big table here. All right, and we can see in the table that it's annual budgets for different programs in Kansas from 2007 to 2010. I am not even going to bother to look through that table right now because I'm going to see what information is important to me. Question number 1 says, which of the following best approximates the average rate of change in the annual budget for agricultural natural resources in Kansas from 2008 to 2010? Well, there's a whole lot of words going on there. Maybe you recognize that average rate of change means slope. Maybe you don't. But at the end of the day, we're talking about agricultural natural resources, 2008 to 2010. Now, if I look at my 4 choices here, they're all per year. Well, 2008 to 2010 is 2 years. So the first thing I'm going to do is I'm just going to take all these and multiply them by 2 to figure out how much it would be for 2 years, not per year. So this would be 100 million. This would be 130 million. This would be 150 million. And this would be 260 million. Okay? And again, I'm not bothering to write out all the zeros. So now all I'm going to do is come up to my table here, and I'm going to look at agricultural natural resources 2008 and 2010. So here's agricultural natural resources in 2008, and here it is in 2010. Which one of these numbers here looks like they would bridge that gap? Choice A is 100. So from here to here, is that a difference of 100? No. Choice B is 130. From here to here, again, is that a difference of 130? And that looks to be a difference of 130. 358 to 488 is 130. Guess what? That is our answer, choice B. Number 2 says, of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the ratio of the human resources program's ratio of its 2007 budget to its 2010 budget? So we're talking about specifically human resource programs ratio 2007 to 2010. Now, if I look at human resources here, 2007, 2010, I am not going to try to figure out that exact ratio. I am going to grossly simplify this and say we are talking about 4 and then 5.9, that's essentially 6. So we've got a ratio of 4 to 6. Now, they give us 4 other choices here. Agricultural natural resources. If I look at that, that's going to be closer to 4, and this is close to 5. So that would be 4 to 5. B is education. That's 2 to 3. C is highways and transportation. That would be 1, and this would be closer to 2, so 1 to 2. And then D, public safety, that's be closer to 3, and that would be closer to 5. So I've got 3 to 5, 4 to 6, 1 to 2, 2 to 3, 4 to 5. Well, hopefully we recognize that 4 to 6 can be reduced 2 to 3. And that means education is the correct answer. All right. On to the next page. Number 3, the equation above expresses the approximate height in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Okay, again, a lot of words going on. Here's what the question is. How many seconds hit the ground? Well, ground, hopefully we know, is a height of 0. So that means this equation right here would be 0 equals negative 4.9 t squared plus 25t. Now, I'm going to show you a way to solve this that your math teacher will be really upset with, because this is never how you're supposed to solve these equations. I'm just going to move this to the other side of the equation. And the reason that's frustrating is because we generally want the variables on the same side. So we get 4.9 t squared equals 25t. And I'm going to do something else that your teachers would not very much like. I'm going to divide both sides by 4.9t. 4.9 and 4.9 cancels out. One of the t's even cancels out, and I have t only on that side. And on this side, 25t divided by 4.9t is about 5. Now, there's just cause for a teacher saying that you shouldn't be doing that, is because when you divide by a variable, you're breaking some rules. Sometimes that eliminates a possible answer. And yes, we are taking that risk. But again, t equals 5. There's our answer. And yes, that is the correct answer. All right, number 5, Katrina's a botanist studying the production of pears by 2 types of trees. She noticed that type A trees produced 20% more pears than type B trees did. Based on Katrina's observation, if the type A trees produced 144 pears, how many pears did the type B trees produce? Okay, again, we're trying to do this quickly. So, in reading this, we could tell that, you've got tree A over here, my fancy tree, and tree B is smaller. So here's tree A, here's tree B. Tree A had 144 pears. Now our choices for tree B are 115, 120, 124, and 173. Well, clearly tree B is smaller, so it can't be that one, so we could rule out that answer right away. All right? Now, it says it's 20% more. 20% more does not mean 20 more. So if B was 124, that would be 20 more, but not 20% more. So we know it's not that answer. So that rules out C. And that leaves us with just choice A and B. So at the very least right now, you can make an educated guess and you got a 50-50 shot. Now, to figure out the correct way, if you did want to do it, is simply this. If A is 20% more, that means it's 120%. When something's 20% more or 50% more, you just add it to 100. If it's 20% less or 50% less, you subtract it from 100. So A is 120%, B is 100%. You could set up a really simple proportion. You could say 120% is 144 pairs. 100% would be how many pairs? And if I cross multiply, we will find that the correct answer is B, 120 pairs. All right, a little out of order here, sorry. Number 4, it says, for a polynomial p of x, the value p of 3 is -2. Which of the following must be true about p of x? Again, this is one of those things, the problem provides us with the answer. If I look at the answers, choice A talks about a 5. B has a 2 in it, C has a 2 in it, D has a 3 and a 2 in it. Anybody want to guess which one is the correct answer, considering that our problem has a 3 and a 2 in it? That's right. D is the correct answer. Now, just to be clear, is that 100% of the time going to work out for you? Is that easy? No, but if you don't know how to do the problem, and in this case, this is a little known thing that you learned in Algebra 2, it's the remainder theorem, okay? But if you forget about remainder theorem, and you just have to make an educated guess, look at the 2 numbers problem, there they are, guess what? That's the correct answer, okay? So, last questions here. Number 6 says a square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths 1 meter, and there are no 2 regions that overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So entire field is 10 meters by 10 meters. all right? So if we look at the choices here, one of the things that you should notice right away is in all the choices, it's the same numbers. It's a 1, 5, and then just a series of zeros afterwards. In other words, this is a magnitude problem, okay? They're not trying to figure out the number. They just want to know if you can understand what the size should be. So let's take a look at these. 150, well that, if we look, is pretty close to what each kid was getting in their little square. So 150 would be for one little square, so it can't be that. Well, we've got 10 little squares here. 10 times 150 would be 1,500. But again, is this the entire field? No. And here's how we know. The field is 10 by 10 meters. 10 by 10 means 100 square meters. There's only 10 measurements here. So this is not enough. So we need 100 measurements, okay? So if we've got 150 in each square times 100 measurements, we just add 2 zeros, and that's 15,000. And there you go. All right. You guys have a fabulous day.